So we want to continue looking at symmetry for two variable equations, graphs. So we talked about three types of symmetry, maybe you remember. We said that first of all, there's x-axis symmetry, then there's y-axis symmetry, and then there's origin symmetry. And we said we established a characterization for each of these types. Remember, for x-axis symmetry, if you have a point xy on the graph, then so is x negative y on the graph. That's for x-axis symmetry. And for y-axis symmetry, if xy is on the graph, then negative x comma y would have to be a point on the graph. And finally, for the origin type, if you have xy on the graph, then both the x and negative y, they're opposites. Negative x and negative y have to be on the graph. So those were the characterizations of the three types of symmetry. Now, we were able to identify whether or not graphs had these types of symmetry just by looking at their actual pictures, their graphical pictures of the graphs. Now, what if you don't have a graph is the big question. What if you just have the equation? Well, we want to learn how to test when you just have the equation without any picture to look at. So for the first type, the x-axis test, I'll write that here in blue at the top. So remember, if xy is there, then x negative y should be there. So it shouldn't matter whether y or negative y is plugged into the equation. If you were to plug negative y into your equation, it should essentially turn out to be the same equation. So what we're going to write for this test, we're going to write replace y with negative y in the equation, and determine if the equation, the new equation, is the same as the original if. New equation is the same. Same as original. Yeah, so the idea is it shouldn't matter whether y or negative y is there. They should be the same. The new equation with negative y should be the same as the original equation with just ordinary y. So if they are the same, then you have x-axis symmetry. If they're not the same, then you don't have x-axis symmetry. Okay, how about the second type, y-axis symmetry, testing for that? Well, remember the characterization was if xy is there, then negative xy should be there as well. So here, if you have an x in the equation, it shouldn't matter whether or not you plug in negative x into the two-variable equation. So it shouldn't matter. So we're going to say, how do we test for that? So test here. How should I write that? I'll put test. I'll call it y-axis test. No, underline that in red, y-axis test. I'm going to say replace x with negative x in equation, and determine if the new equation that's the one with the negative x in place, is the same as the original equation, same as original. That's the one with ordinary x. So if they are the same, then you have this kind of symmetry, right? It shouldn't matter whether you have x or negative x. So if they're different, if the equations are different, when one has x in and one has negative x, and if they're different, then you don't have y-axis symmetry. Now for origin symmetry, let's do these in green. So if xy is a point on the graph, then negative x and negative y should also be a point on the graph. That's something we established. We're going to write here origin test. Origin test. So here you might guess we're going to replace both x and negative y. I'm sorry, x with negative x and y with negative y in the equation. So replace x with negative x, and y with negative y in the equation. So you're going to have a new equation with negative x's and negative y's replacing the old x's and y's. And determine if the new equation is the same as the old, and determine if new equation is the same as the original. If it is the same, then you have this kind of symmetry. If not, then you don't have this type of symmetry. Yeah, so we want to actually see some examples of this in practice. So some exercises. So determine if the graph of the equation has x-axis, y-axis, or origin symmetry. So we want to test for all three types of symmetry, all three types. So here's our first example, first equation in two variables. It's going to be x squared minus y cubed equals 64. All right, so we're going to start with the x-axis test. I'll just write x-axis. So remember what we do. We're going to replace y with negative y, right? Y with negative y. I'll draw an arrow. Replace y with negative y. So let me draw my equation. I'm going to make a template where I have what? X squared minus a blank cubed equals a 64. So in place of the blank there in parentheses, I'm going to put my minus y. A minus y, or I'm replacing the y with a minus y. And now we're going to simplify. So the x squared stays x squared. And we have a red minus sign. Now anytime you have a cube power, anytime you have any kind of odd power, you can extract the negative from the parentheses. So that negative that's within the parentheses can come out, and you're going to have a minus y cubed. Minus y cubed, yeah. So odd powers, you're allowed to extract negative signs from odd powers. And this is equal to 64. Now if you clean that up, the double negative makes a plus. So you get what? X squared double negative x plus y cubed equals 64. Now the question is this equation, x squared plus y cubed equals 64, is this the same as the original? No, it's not the same as the original. So since it's not the same as the original, there is no x-axis symmetry. So I'm going to put a little cross there and indicate no, we don't have that kind of symmetry. All right, let's check out y-axis symmetry next. What color are we using for y-axis symmetry? Who knows? Oh, maybe red. I don't know. Whatever. Oh, that should have been blue. Huh. Well, anyway. All right, so now we're doing y-axis symmetry. Come on. Testing for y-axis symmetry. So with this type, we're going to replace our x with a negative x. In the original equation, let's go to the original equation. So what do I have? I have, let's see, okay, I'm going to do a blank squared minus y cubed equals 64. So here's a template. Instead of putting an x in where it normally goes, in place of that parentheses, I'm going to put a negative x. Right, negative x is replacing the x. Now what happens when you square a negative? Squaring kills off the negative. So literally we're left with an x squared minus y cubed equals 64, right? X squared minus y cubed equals 64, right? The square killed off the negative within the parentheses. Even powers do that, right? Even powers kill off negatives. Now, when I look at that, x squared minus y cubed equals 64, that's actually the same as the original equation, right? X squared minus y cubed equals 64. So, yes, this is the same. So, yes, there is y-axis symmetry. Symmetry. All right, so now we just have to look for origin symmetry. Guess we'll do this one in green. So with this type, remember we replace both the x and the y's with negative x and negative y respectively. So we're going to replace x with negative x and y with negative y, double replacement. So you have to go back and remember, what was your original equation? Yeah, it was x squared minus y cubed equals 64. So we're going to make a template with that. Make a template with that. We're going to have blank squared minus blank cubed equals 64. So where the x was, we're going to put a negative x. So we're going to have a negative x in parentheses squared minus, where the y was, we're going to put a minus y. So there we're going to have a minus y in parentheses, and then cubed equals 64. We want to clean that up, right? We want to clean that up. So first of all, the square is an even power. It's going to kill off the negative inside of parentheses. So we're going to have x and then squared, right? That negative is gone. And then minus. Now we have a minus inside of a parentheses with an odd power. Remember, anytime you have a negative in parentheses with an odd power on the outside, you can extract the negative. So odd powers do not kill off negatives. They allow you to extract the negative. So we have a minus negative y cubed. That's equal to 64. So again, it looks like we have a double negative, right? We got x squared plus y cubed equals 64. And that is definitely not the same as the original equation. What was the original equation? The original equation was x squared minus y cubed equals 64. We have x squared plus y cubed equals 64. So 64. So this is not the same as the original. I'll just put a cross out here on the side to indicate no, it's not the same. So here we don't have origin symmetry. No origin symmetry. So it looks like we just have one kind of symmetry. The only kind of symmetry that we have here is, what was it? Y-axis symmetry. All right. So let's do a few more problems just to get some practice.